Mini.
Hello, sir.
So first section, you have to uh, tell about your background, about the education and all things
Yeah,
skills.
yeah, sure. So, like, I will start with my name. My name is Mini Parihar. I'm from Agra. I
Okay.
have done my BTech. I have done in 2022 my BTech from the IBS CTC with 7.86 CGPA, and also I have done my 12th and 10th from the Agra, like from Milton Public School and SCCI school. If I talk about my subject, which in which I am good, I'm preparing. So digital SDA, CDC, and SP and UVM also. Right now, I'm uh, don't know much aware of the UVM. Only know the basics part of the UVM. I
Okay.
have covered some project in Verilog, like synchronous FIFO and EPP protocol and traffic light controller, clock clock generation and memory generation also. I mainly focus there on the TB for the verification purpose. And yeah, there are many more projects, like small projects, not too much big.
Okay.
And if I talk about my hobbies, then obviously watching movies and web series and traveling and sketching also. I like I like to do sketching very much. And also fashion designing. It is just a hobby. I design many dresses for my sister work. Mm, uh, that's it. Thank you.
Okay. Thank you, Mini. So we start with the first thing, from the ASIC design flow. Do you know ASIC design flow?
Yeah, sure.
Can you
So
tell that?
yeah, so in ASIC design flow, we start from the specification. So first we take and consider that the specification what should be done uh, in our chip or what the customer want. Then we go for the architecture section where we design the flow diagram type of thing, like how the data will be transparent, what things they want logically. Then we go for the RTL section where we design the RTL code for that specification and verify that with the RTL verification. Then we go for the simulation there, with the system Verilog and other things which support it. So we go for the simulation purpose. There we apply different stimulus and whatever uh, functional coverage and everything to check our design, like it is working perfectly and the code is perfect or not. Then we go for the DFT, where we design for testability. It is designed for testability. We add some component and design so we can easily design test our design after the manufacturing. And after this front end part completed, we go for the back end side where most of the work done like uh, related to the layout development, which comes in the physical designing. So we develop the layout where partitioning and floor planning take place and routing also. Then we verify that also, everything is working fine or not. Then we go for after that we go for the manufacturing and sign off section. After the manufacturing, we verify it again as we develop in the DFT. So that with the help of that we um, uh, verify that our chipset, and that's it. Like in that way it works.
Okay. So coming into digital, do you know about the latches and flip flop?
Yes.
Uh,
Yeah.
can you point out some differences between that latchet and this flip flop?
Yeah, sure. If we go for the latches, then main difference is that latches are the level trigger. So where it dependent on the input, and also whenever there will be a level, they change our value. But if we talk about the flip flop, then these are the age triggered. So they are. In the flip flop, there is like we do not have the glitches and they are synchronous. Whereas latches, it is not the edge trigger; they are level trigger, so there can be many problem there. Um, and we go for if latches, then it is a simpler one also. Flip flop are made of the latches, like with the master and slave configuration and with the ace triggered clock, we can say. So like it is more complex in design as compared to the latches. So if we go for the transmission gates also, so the latches have less gate as compared to the flip flop. Flip flop needs more gate to implement the circuit also. And latches mainly used uh, like uh, for like to pass the value, and in pipelining and this type of thing we use mostly the latches. And flip flop we use it as a storage element, which is like a in latch we can also, but it is not effective one. So we go for the flip flop for storage and count, generate the counter and all.
Okay. So list out the many points like. So do you know about the race around condition and the flip flop or latch?
Uh, i- yes. Yeah, in latches there can be a race around condition toggling. A race around condition happen that when there is a toggling, so that there is some condition that our output is toggling in between, not giving the proper output. Uh, it is level triggered. If it is positive level triggered, then in that positive level, it changes rapidly in multiple number of times. So this condition is called the race around condition. So that's why we go for the flip flop one. So we cannot have the race around condition there.
So in SR flip flop, race around condition will be there or not?
Uh, in SR flip flop, no, there is no race around condition because at the time where mainly the race around condition occur, so it's not in SR flip flop. Like
Like,
it is
can you draw the like SR flip flop and give the input at 1 1?
yes. Okay.
What will
Should
be
I
the
show? Should I show my screen or just draw in my notebook?
you can draw in notebook, and so and also explain the what will be the like output in 1 1 combination.
Okay, sure. I just draw the block diagram, or should I draw the gate level of thing in SR? Like uh, I just draw this block.
No, you have to draw the block diagram to
Okay,
explain how like 1 1.
like
If you apply
I
the yeah, if you apply the combination 1 1, then how my output is coming.
show. Here is the diagram. Is it visible? Is it visible or not? I don't think so. Are you able to see it or not? Hello, am I audible?
Hello, yes. So you design with like NAND based flip flop.
Yeah. I simply designed with an end base.
Don't cover your face, like it
Flip.
will be blurred.
Okay.
So okay, okay.
I.
Open like any NAND based flip flop and explain about that.
Uh, by sharing the screen.
Oh, yes.
Okay.
One minute, I'm sharing. Huh?
Okay. Okay. Okay.
Can you see that? Hello?
Sorry. Yes. Yeah. It is visible. Can you enlarge it a little?
Hmm. It is okay?
It is still small, but yeah. Okay. It's okay. Okay. So. mm Okay, when we apply the s is equal to 1 and r is equal to 1 here,
Yes.
so what happened that s will tend to make the q is equal to 1 and r is tend to like q is equal to 0 as q bar is equal to 1. We can see in that way. So like if we consider a condition, mm, it is-
Apply all the stimulus like start from 0 0 all the combination like you have 2 bit like 0 0 0 1 1 0 1 1.
okay. Um, the time when we apply the s is equal to 0 and r is equal to 0, that time if we go for the like NAND table, so then clock is like high, so it is 1, it is 0, and the clock is high. So that time what happened? It shows the we have the NAND gate. Okay. So that time here, like at the 3 point, we will get the one value here, and if if q was uh, there will be q bar. Here we have the one, and like it depends on the q bar. So like previous value will be stored here at the q. When we apply the s is equal to 0 and r is equal to 0, and when we apply s is equal to 1 and r is equal to 0, that time mm, s is equal to 1 and r is equal to 0.
And let it make simple like apply only s as 0. What will be the output of that NAND gate?
S, what you say?
S equals to 0.
Okay.
Then
When
what will be the
when
output?
when s is equal to 0, that time the s is equal to 0 and clock is high. That time and will be the 1 here here at the point of the 3. NAND gate will give the 1.
So when you apply 0, it will be 1. Okay.
Yeah.
When then r equals to 0, then what will be the output?
When r is equal to 0 and clock is high, it will give it as the 1 here.
Okay. So now these both gates have 1 1. Okay.
Yeah.
So
So
then
like we can take a
explain from
case
here.
like yeah. What?
Explain from here. Like 1 1 you got a.
Okay. I get the one here and the one here. Like if we take a previous condition, there can be some value. We consider it as a q is equal to 0 and q bar is equal to 1 here. If q is equal to 0 and we have some we get the at the 3.1 in the like below circuit, below like this one. So I am not able to share the screen. Okay. So this will give at q1 is equal to 1 because we have a q as 0 and from the r place it is coming as like it is 1 and q is 0, so it will give it our q dash like q bar is equal to 1. As q bar is equal to 1 here, and we consider it also in that way, so like here in above we get the at the 3 point as 1 from the S circuit. So it was 1 and we are getting at the second point also 1. So 1 and 2, these two places we have 1 1. So Q will be 0 there. So like as previously we consider it Q is 0 and Q dash is 1, and now it also we have Q is 0 and Q dash is 1. So like it is a hold condition. It is a holding the previous value.
Okay, let's leave this question. We'll discuss later.
Okay, okay, so
Next question is like again on the race around condition. Like, what do you mean by like race around condition? What is
like
the significance like?
it is like if we explain it in a simple way, we can say the race around condition is uh, mm, mm, it is like our output is toggling. It's not stable there. So it is unstable there. It is just toggling in between when we S and R like J and K is 1. So that time for like it should be give output only once, but it giving is multiple times. So which we do not want. So it can be like not good for us like next circuit also. So toggling multiple times in a specific time period, which we do not want.
Okay.
Yeah, racing is happening between like Q and Q dash. It's toggling just
Okay.
changing the
Okay.
value.
So next question is like, can you draw the like XOR gate using 4:1 mux?
4:1. Sure, sure. I have given there in like I1 and I2 is 1 1 and I0 and I3 is 0 0. So it will give the like I have written the ex- expression
Uh,
also.
don't face your cover, like don't cover your face. Don't cover your
Mm,
face. Yeah, yes.
it is now okay.
Uh, okay. Like, can we use XOR gate as a buffer?
Exorcate as a worker.
Like, what will be the like combination? Like,
Okay, let me see. As a worker. So like for that we have to ground one input there. Yes, we
so
need to like
you draw anything?
I can try just to make a table here. Uh, okay, let me draw.
When you show like, don't cover your face, huh?
Okay, okay, sure. ground the one input from the
Oh,
absorb.
okay. So you have grounded one input. Okay. So
Yes.
what output is coming?
It will give the A. Mm,
It is working like buffer.
It will be a buffer. It will act as a buffer. Yes.
So what will be the case of like inverter?
So for the inverter, I think we need to do it opposite. Like our one input like be connected to the like VCC. Like make it one
Like apply one and see
and
the
give input.
apply input and see the output. What output is coming? Acting like a inverter.
Right. Yes. Yes. It will act as a inverter. Inverter.
Okay. So what do you mean by like synchronous and asynchronous circuit?
Okay, like synchronous circuit, we take like when our design is synchronous, it means like it depends on the changing of output, or output will be depending on the clock only. Like whenever there will be the clock high, that time we get our output. Otherwise, we do not like in between. If there any change will be there, so we do not consider that. It will only catch the value at the positive ways or the negative ways when like whichever we consider. And if we go for the asynchronous one, so it does not depend on the clock. Like it depends on the input only in the asynchronous circuit. And asynchronous circuit are more simpler than the synchronous one. And obviously the like speed is slow in the asynchronous circuit if we compare to the synchronous one, because like they are clock driven, but asynchronous is not. It depends on the like previous out, output, like previous delay also.
So which is faster?
See, synchronous is more faster than the asynchronous.
Okay. Okay, let's move to the next question. Like, what is the combinational and sequential circuits?
Okay, like if you go for the combinational circuit, so like there is a no control signal is there. Like in sequential, we have some control signal which is clock. Like, it is the not the main difference. The main difference is that combinational circuit doesn't depends on the like previous input whatever we are applying there at this time. And whereas the sequential, it depends on the previous state also, like what was the value of the previous output. So in in sequential we have some memory element also and a clock also, but in the combination, if we talk about these two, like we do not have any clock signal or any type of memory element which can store the previous value because we do not need it. And if we talk about in like speed, so like the combination one is like faster than the sequential, because sequential is depending on the clock, but that combination is only depending on the input. Whenever we apply, we get our value, get our output. That's it. And
Okay.
yeah, okay.
Can you define like what is frequency? But just basic question.
Okay, like fluctuation per second, like our wave is like our output is how much fluctuating in that time period for 1 second. We make it as a frequency there.
Okay. So do you know about the Mealy and Murray FSM?
Yeah. Yeah.
some point out some differences like melee, what is more?
Yeah, sure. Like if we go for the melee circuit, then output of the melee circuit is depending on the input and the present states only, like both input and the state. In Moore, it depends only on the state. It nothing to do with that input, whatever we are applying. Whenever there is a that desirable state come, our output will be coming out. And if we go for like uh, in the melee we like think in that way. So okay, melee give melee output is asynchronous in nature, like it depending on that input also na. And if we go for the Moore, so it's synchronous in nature, like whenever there is a state changes, which will be when the clock is come, so output will be R high, so it will be synchronous. The output is synchronous, and so if in that way, Moore is more simpler in designing, and as it is and speed of the Moore is more than the Melee, and Melee is complex in designing as it depending on the input also. And if we draw the state diagram for both of them, if we consider the states there, so Moore has more states than the Melee. So the hardware is also more for the Moore circuit than the Melee, and mm, mm, that's it. There can be more like differences also.
Okay. Uh, do you know various step how to design a sequential circuit?
How to design a sequential circuit?
Means
Okay, what will be the steps in this?
okay, yes.
Okay. So, for designing sequential circuit, we need to know first what are the inputs and how many outputs we need. Then, mm, okay, we need to make the table also, that excitation table and the characteristic table, and of the flip flop or the component by which we want to make a circuit, and we uh, take our output according to the present that excitation table and the characteristic, and draw that. Like I do not know how to elaborate it in that. Sorry.
Okay. Write down one question like you have a 128 GB memory,
120 GB memory.
16-bit wide. Then
Okay.
how many address line will be required?
Sorry, I'm not able to solve in that. Right now, I don't know why.
Okay. Leave that.
Okay, it will be in that way, like size is 6 GB. So and width is 16 bit. So we divide the size over bit and take the log of that value, that depth we get. So that will be the address size there. That way we
Okay.
solve it.
Let's move to the next question. Like, do you know about the glitch?
Yeah, like glitch is something we can disturbance in between. So there is some disturbance in between. It's called the glass, which which is come in the latches, which are the level trigger. So there is some change in there. So that time, it shows some glitches there. Mm, it's some type of hazards, we can say, like due to some delay in between the gates, so there can be a condition which should not be there, but it shows that at output a static 0 and static 1 hazard there. So we want the output as 1 there, but due to some delay in the gate, which is like a different path. Due to the different path, there can be a condition which gives some erroneous uh, output at the output, some erroneous value.
Okay. What is metastability?
Metastability is uh, like when we have the different clocks there, like mainly if we do not go for the different clocks in same circuit, if there can be a condition that setup and hold violation will be there, so that time there can be a condition we don't know like what will be our output. It don't know, like it can be zero or either one due to the violation. So the input is not captured properly, so that's why we can't be like sure about the output. So it's called the metastability. It can be there can be different condition, like there is a two different clock. That time also uh, that setup and hold violation will occur, due to which like metastability can occur.
Okay. Can you define like setup time, hold time?
Yeah, sure. Like generally we take it setup time is a time, like setup time is a time then the input should be present before some time of the clock, so it can properly capture there. And hold time is the time like after the clock has come, like our input should be stable for some time uh, to latch up the value properly. Like, it is a time, there's like time before and after the clock. For there, the input should be stable, not changes. That is called the hold time in the setup.
Why do we need that setup time, hold time?
To capture the input properly, we need the setup time, and to latch the output properly, to latch the value properly, to get the output properly, we need that of hold time, because there is a transition gate for some circuit. Whatever we like, basic level we draw flip flop, there is a transition gate. There will be some path and delay also. So for that purpose, we need some time to properly capture the data and properly less the data. This is called the like hold time in the set.
Okay. So let's move to the Verilog. You
Yeah,
know Verilog also. So
yeah.
in
Okay,
Verilog.
can you give me 1 minute? I'm just
Okay.
okay. I'm just coming in. I'm sorry for that.
Oh, yes.
Yeah, I'm sorry for that.
So first question, like, how do you differentiate like what is reg and what is wire?
Okay. Like wire is a continuous driven, and race can hold some value for some time. That way we can differentiate.
Like, what is the default value of reg?
Okay, in that also, like default value of race is the X here, and the default value of the wire we take it as a Z, high impedance.
Okay. So initial block is synthesizable or not?
Initial block is not synthesizable.
Always not.
Yeah, always block is synthesizable. We mainly use in our RTL code to always.
Okay, give me 1 minute. Someone is my Torah.
Sure, sure.
Okay, hi.
Hello.
Oh, yes.
Yeah.
Can you write a code for D flip flop?
Okay. Okay. Sure. always look like module and that I don't like. Are you able to see?
Yes, yes.
Is it fine or should I write the module and
No, okay.
what?
Okay, so it is reset high or low?
I make it a reset high. Should I show it?
Show me again.
Yeah.
Okay. Can you write a code for mux? 4:1 mux?
Yes, sure. Mm,
Uh, just move
it's
back.
not clear enough. Is this now?
No, no. Just move back. Move back.
Let
Uh,
me. I think I have okay.
okay, go
Here
open
can
some editor. Okay. Yeah.
I can change this like blurred and this.
No, no. Open some editor from your end and write code.
Okay. Yeah, yeah, sure. It is visible.
Yes.
Should I write the logic only or the full code?
Logic, write logic, full code.
Full code.
Yes, full code.
Okay. Yeah. Okay. Okay. Mm, And mm, mm, Here it is.
Enlarge that one code. Okay. So, what do you mean by your star?
What this is star sensitivity. Okay, it means whenever there will be any change in the input, so it will be triggered, and the statement which is in this begin and end for this always block will be executed.
Without a star, can you write?
Without a star, I can yeah, sure. Yes. Or change of line. That way. There any change in input or the select line? It will be triggered.
Okay. If you miss to write like S, then what will happen?
Or it will like the statement in it will never execute. Like it totally depending on the S. Now, whenever the S change, we are getting output as the input. So it will never. It will be triggered, but the case statement will not execute there that time. So we are not going to have any value there.
Means simulator will enter in this always block or not?
Simulator will enter in always block as I have written I. You are saying if I remove only S, it will enter, but this case statement will not execute because it is depending on S. So it will not execute.
Okay.
Okay, it will execute, but like there can be a condition like it will depend will be the input only. Like input is changing, that time it is checking for the S. So it is not dependent now the S like select line. The main dependency will be on the I. Whenever like my input is changes and there is a if no change in the S, so it will not like execute the statement will the was before it will be always will be there.
Okay. Why you written like blocking statement?
Okay, it is a I have written blocking because it is a combinational like design, so that's why we mainly use the non-blocking for the sequential design purpose. Whenever we have the sequential design, that time we go for the non-blocking.
Okay. So why default statement?
Because if can be condition in test bench because like the here I can give x or any value. That time what happen? Like there should be some value. Otherwise, latch info will be there. Something erroneous value will be there. So that's why I have given some value by default. Like if none of them will be executed and there will be some value of this which is not this, then that time the default condition will execute it. That
Means you are saying if error will come, if glitch will come, then this default will statement execute.
yes. Yes.
Okay. Like you have written here and case line number 15. What is it? Can you define this?
Okay, this end case, like whenever we start the case, there should be some end case will be there. Like there will be error, we cannot.
Like you have written
Be,
in line number 12, no?
okay, there is a mistake here. I should make it clear. Okay, yeah. Why it isn't? Yeah, I have written 12. I was writing the end module there. It is why like mistake become the end.
Okay, okay.
Yeah.
Means, do you know how to avoid latch?
Mm. So like by using this default condition, we are avoiding the latch of here. Latch here. Latch info will be avoided by using the default condition. Otherwise, like it is stored, like there can be a latch if I do not add this default condition. There can be some cases.
Uh, can you give 2 to 3 scenario like how we are avoiding latch coding style?
Like if I'm in this only case statement, like
Any scenario you can give like
okay, like mm, if we go for the if else condition, I have written something like I have written like uh, if RSTI or some statement there, and if I do not use the else statement there, so like at that time, uh, if not, if opposite of this condition will occur, like if this is not the condition, something else will be condition. What should be there? So at that time there can be erroneous value, and like this will be less there, like whatever we are generating there. So this can be condition for like lecture of the test data will be occur.
okay. Can you write a code to generate a 10 megahertz clock?
10 megahertz clock, yes, sure. Mm, let's see. Mm, okay, so like for megahertz only, so like I can use this formula for the megahertz. Like if here I am using it as nanosecond, so this can be the like I can give anything. Like frequency is equal to 10 megahertz.
Did you finished?
Yeah,
Okay, so what is your module name?
I just to make it clock. It should be clock something.
Okay. So in line number 10, you written like always as TB by 2.
Mm,
What does it mean?
it means like this will be executed always. Uh, the clock will be inverted the value of the clock after the TP by 2. I make the 50% duty cycle there. Like every
Means
yes,
like your screen is not visible for code like.
yes. I was trying like yeah here. Okay. I make a clock here and then this.
No, go to your code.
Okay.
Hmm. So what is the unit? I want to know this.
Here nanosecond I take the unit as
Okay.
unit is a nanosecond there. I use this formula also for the taking the nanosecond and giving the frequency in megahertz.
So you have to define. Okay.
Okay.
So this is generating
Yeah, it should generate
which frequency?
uh, 10 megahertz.
Okay, it's like it's 1 hour. Uh, okay, let's end this mock. We will take your mock on that like projects what you did on next mock. Huh?
Okay, sure.
So
Should I? Yeah.
coming to your feedback and suggestion, this is friendly suggestion. Okay,
Yeah, sure. No.
like you can correct me also. Like in the first section, you told about yourself. Huh?
Yes.
So you told about your hobby also. Huh?
Yeah.
So my suggestion is like for the technical discussion, don't
Mm-hmm.
tell about this hobby. For the
Okay.
for the HR round, you can tell.
Okay. So I should like did just remove that part of the hobby if there is a technical interview.
Yeah, it means technical
Okay.
means he want to know about your technical background, like what is your education, what
Mm-hmm.
is your skills, like okay,
Mm-hmm. Okay. Sure.
what you know about this design field, huh? All the things.
Mm-hmm.
Like when you asked about the latch and flip flop, you told about the pipelining also. Like my suggestion is don't give many points.
Okay.
Like give point which you are very confident. Okay.
Okay.
So I noticed also one thing like in case of synchronous and asynchronous. Like you told like asynchronous it's slower.
Yes.
Means we are applying directly a reset signal and it doesn't depend upon the clock. So it is
Yes.
slower or faster.
Like it is for the reset condition. Like for the output you are saying only that time there is a it is more faster, but if you go for the circuit and whole scenario, that time we can see it is slower in that condition, because it is depending on the previous like previous block. Then the clock will be going to that, if you consider that mm,
Okay, that thing you can see it later. So coming to my next observation, like I noticed, like in NAND-based design, I told you like design a flip-flop using NAND-based, huh?
mhm.
So you told like there will be no race condition in 1 1
SRH.
0 0. Like you can see it also, huh? Applying 0 0 1 1 in all the flip-flop, like D flip-flop, T flip-flop, JK flip-flop, SR
Mhm.
flip-flop. So in case of this flip-flop and latch, there will always be a race condition. Okay, but only in the JK flip-flop or T flip-flop or D flip-flop, there will be no race condition. You can see it later. Huh?
If you go for the waveform and the circuits, that time we take the restaurant condition in JK, but not for the SR. It is not generating the output at that time, so they can how can it there will be a restaurant condition in SR? Let's.
Yes, in a SR flip-flop, like race condition will occur when we are giving the input at same time. Like you have two NAND gate.
Mm,
You are giving the input at same time. What will be the which gate will come output at first? Do you know? No one
okay,
can tell because
in
it
that
depends
way.
upon the fabrication.
So we call it as a restaurant condition or some glitch there.
No, no, it's like a unknown state. So we call it as race. It is racing. We don't know what will be the output.
So, what I consider there, a racer and condition is racing between that Q and Q are changing rapidly in a single time. But I think if we go for the delay and these things we are applying at the same time, then there is a change for some time. You are saying this will be only some time now, because uh, for SR, uh, that you are saying that they can we are applying it at the same time, there can be some delay, so it will be something like a glitch, not the resonant condition. I'm asking, I'm not.
Okay, okay. Now you can apply all the inputs, all the combination 0 0 0 1 1 0 1 1 in all the flip
Mhm.
flop. Then you can like be clear. In which case race around condition will be there. Huh? Okay. So for the memory part, like
Yeah,
for the address, huh? Number of address, this can be asked in interview. You can prepare for that. Only a formula will be there.
yeah, yeah.
So last suggestion is for the to be means give to be point. Huh? Answer will be to be point to the point. When we ask
like
for what is difference between raise and wire,
mhm.
so
So they should.
two point. Huh?
Yeah, yeah, I didn't say that default way,
Yes,
but
2 to 3
it should be.
points you can make. Huh? For
Okay,
the practice purpose, you can also make your videos on videos. Huh?
okay.
Okay then. If we will have time, then in the another day, we'll ask on the project
Yeah, yeah, sure, sure.
because
Thank you so much.
on the in the interview, like real interview, they will be
Mhm.
more focused on your project.
Okay, so most of the question will be related to the project. What I have done according to that, they fabricate the questions on that.
Yes.
Yeah. So when will you able to conduct a mock interview for that?
Uh, okay. Tomorrow. Tomorrow you prefer?
Tomorrow I have some written test. So like
Okay.
day after tomorrow. Yeah.
When you free, na, then ping Rajat. They will
Okay.
they will
Yeah.
attend with anyone. No? Okay.